A quick notational reminder, we say that A is an invertible matrix if we can find some other matrix B so that AB is equal to BA is equal to the identity. This is kind of like the multiplicative identity. So for example, if A is equal to 1/3, then its multiplicative inverse, B, would be equal to 3. Okay, and the notation that we use for such a matrix is this inverse notation. So in this little example, we would say A inverse equals 3. All right, we're going to look at how to build these inverse matrices in the 2x2 case. So there are a couple of strategies to use. We're going to start with just a formula. So if A is equal to A, B, C, D, then assuming it exists, A inverse is going to look like 1 over AD minus BC times D negative B negative C A. What we've done is we've flip-flopped these elements on the diagonal, and we've negated the elements that are off of the diagonal. And then we multiply by 1 over AD minus BC. Okay, notice if AD minus BC is equal to 0, A inverse doesn't exist. And it goes the other way also. If it's not equal to 0, then this formula gives it, A inverse. So let's try this out with an example. Okay, we're going to look at A equals 1/2 2, 1/2 6. So first, let's just check to see whether this denominator AD minus BC exists. We call this the determinant of A. So we have 1/2 times 6 minus 1/2 times 2. Or 3 minus 1 is 2. Okay, so since this is not equal to 0, A inverse exists. Okay, so A inverse, what does this look like? We're going to take 1 over this number that we got. So 1 over 2. And then we're going to swap elements that are on the diagonal. So this gives us 6.5. And then we're going to negate the off diagonal elements. So we have negative 1/2 and negative 2. And it's a little bit tidier to read sometimes if we multiply in. Let's do that here. So each element gets multiplied by 1/2. So we have 3, negative 1/4, negative 1, and 1/4. And this is our inverse matrix. We can check just by multiplying A and A inverse. Let's try that out in the next slide. When we're calculating inverse matrices, it's easy to check whether or not our solutions are correct just by multiplying out. Remember from our definition, we found the inverse if AB is equal to BA is equal to the identity. So we're expecting to see the matrix 1, 0, 0, 1 out of this. All right, let's do this matrix multiplication. Okay, so we have 1/2 times 3 minus 1/2. We have 1/2 times negative 1/4 plus 1/2 times 1/4. We have 2 times 3 plus 6 times -1, and 2 times -1/4 plus 6 times 1/4. Okay, and now we'll do some simplification. So 3 1/2 minus 1 1/2 is going to be 2 1/2 or 1. -1/8 plus 1/8 is 0. 6 minus 6 is 0. And -1/2 plus 3/2 is 1. All right, we got the identity. And I'll leave it to you to check whether or not A inverse times A is equal to the identity. It's going to turn out that if one of these pairs gives us the identity, so will the other one. Great.